Hello students, let us continue our discussion of the type integration by parts. What we have in this module, the very first question looks like this. Integral of sin x into log of cos x dx. Let's see how to solve this. Let's rewrite the question and I'll just reorder and rearrange the question. We'll write it as log of cos x into sin x dx. Why did I do this? Because I observed something. Yes, log of cos x. My dear students, we know that the standard function we have studied till now is log x, and log of cos x becomes composite. Composite functions cannot be integrated directly. I believe by now we are clear with that fact. So if I have a composite function, I am supposed to use a formula. We cannot apply any formula in this case, so I am supposed to use a substitution. It's but obvious the substitution will be cos x is equal to t. So if cos x is t, we get minus sin x dx is dt, or I can say sin x dx is minus dt. So the integral will look like integral of log t into minus of dt. Now my dear students, let's put the minus outside. What I'll get is log t dt. We have seen in the earlier module that if I have logarithmic function and there is no second function, the second function will be taken as 1. So we'll write here log t into 1 dt. Once this is clear, just for your revision, let us take the set of functions which we can have. Logarithmic function, and what I have told earlier is one we will be taking as algebraic. So it is very clear which function is u, which function is v. Now let's proceed to apply the u into v rule. Now for me to apply the u into v rule, we have identified which function is u, which function is v. There is a minus, we'll keep it outside the integral. So we'll get minus of log t into 1 dt minus d by dt of log t integral of 1 dt the whole dt. That's our rule. Is that okay? We have applied the rule. What I need is integral 1, which is t. That's it. And derivative of log t is 1 by 2. So let us see what is the next step. So it will be log t into 1 or integral 1, which is t, minus integral of d by dt of log t was 1 by t, and integral of 1 was t. dt has to be there. Now my dear students, you very well know that t will cancel out here. So we'll have a minus outside, t log t minus of integral 1 dt. Now further if I go, I will have integral 1 as t. So now my dear students, you can very well observe there is a t common. So it is equal to minus of cos x log of cos x minus of cos x plus c. What we are doing is we are resubstituting the value of t, and in the next step I will take that cos x common. So we will get minus cos x into log of cos x minus 1 plus c. Now my dear students, had you remembered the shortcut, you would have directly got this answer. So that's why I had told in the earlier module that this is important. Integral log x should be remembered. This was how you will solve in the boards. Now let's take one more example which you should try on this. So that is log of log x divided by x. Let's see the next example which we are supposed to solve. Integral of x cube e raised to x square. Now my dear students, x cube e raised to x square. We have x square in the power of e. So e raised to x square, that x square makes it a function, and function in the exponent here. So we can call e raised to x square is a composite function. And if it is a composite function, now I am clear, we will use substitution. So let me write the next step. Let's first write e raised to x square. I am not going to write x cube as it is, but I rather write x cube as x square into x. So I will split that. Why we are doing this? I am sure you are clear about it. In the next step, what we are going to write is let x square is equal to t. If I am writing x square is t, I know I have to differentiate, and on differentiating what we get is x dx is dt by 2. So that x was required with dx, and that's the reason we split x cube as x square into x. Now let us apply these changes to the integral. So the integral will be nothing but t e raised to t into dt by 2. Is that okay, my dear students? Let us see further. That is half t e raised to t dt. Again, if I talk about half integral t into e raised to t dt, as per the rule, what we will get is t will be taken as algebraic, so it will be u, and e raised to t is v. So what I'll get is t e raised to t integral e raised to t dt minus d by dt of t integral of e raised to t dt the whole dt. Is that okay, my dear students? We have already seen this example in the very first module. Now let us proceed further. Half as it is, t into e raised to t will be, this is what we will be getting, minus derivative of t is 1 and integral of e raised to t is e raised to t. Now in the next step what I have is very simple, integral of e raised to t, that is nothing but e raised to t plus c has to come. Now my dear students, what are we supposed to do here? We are supposed to take that e raised to t common. What will be left is t minus 1. Question was in terms of x, so let us resubstitute the value of t. T is nothing but x square. So let us write here the final answer as half of e raised to x square into x square minus 1 plus c. That's your final answer. Again my dear students, had you remembered the shortcut, that is the integral x e raised to x, you would have got the answer directly by applying the formula. Now based on this, what you should try is this particular example. That's all I have in this module my dear students. Thank you very much.